But the same thing, that these formulas that we derive and these things we develop with respect to what are called non-characteristic assumptions, first, they're very local, so they don't apply to the solution of, say, a PDE on a manifold entirely. They only apply, say, in a coordinate patch, and only for small time. And they have these, these weird behaviors, right, that come up, just like in the very simple quasi-linear case. But yeah, I think that was the entire section. I think the next order of business is to determine where we want to go from here. We can cover the rest of the material in Chapter 1, but personally speaking, I don't want to. What do you guys think? I mean, just glancing at this, does it look like it's something that we want to do in a PDE seminar?
We're on 15 now.
I mean, it'd be fun to say go into relativistic motion, but it's not really a PDE's topic. I mean, in some sense it is, but not how it's presented here.
I think I'd be up for going over the completely integrable Hamiltonian systems, but I think just that for the rest of Chapter 1.
Okay. So if that's the case, what I might do is I might ask Dr. Avalidi to give maybe a better summary of this section, maybe anything I might have missed. And then to do 16, unless anyone wants to do, unless you feel like doing 16.
I haven't read it yet,
So if you want to take a glance through it. The other topic, the other thing we need to talk about is where do we want to go? How much time do you guys want to spend on any of these topics? So Dr. Evermedy's suggestion was to briefly, in a few days, cover all of chapters, say, 2, 3, and 4. Do a brief review of them, and then focus on 5, which in some sense is logical. Elliptic equations are sort of a nice way of doing things. My only worry is that if we do that, we miss a lot of, the geometry stuff that he's going to be bringing in. And we miss a lot of the analysis stuff about proving existence of solutions, which is done, for example, at the beginning of Chapter 5, existence and regularity of solutions. In order to even discuss that, we need to have the machinery of Chapter 4. I do think that in a seminar, it wouldn't be worth their time to go through Chapter 4 in detail. That's very hard functional analysis beyond what 577 teaches. But it might be nice to just go through the theorems and try and connect them with why we care and the objects, what a Sobolev space is. But I kind of also think it might be nice to start with, chapters 2 and 3, where we have things like Fourier series that we all, have covered hopefully early on, and Fourier transforms, and then there's some discussion of distributions. So it might be worthwhile to start at the beginning of Chapter 3.
You should do 3A just for the title. The mighty Gaussian and sublime gamma function.
But yeah, I mean, those are my thoughts. What do you guys think?
I agree. I think 3 would be a good springboard.
Yeah.
Okay.
Yeah, and I'd be up for going over 16. Again, probably not too in-depth, kind of cover what to do here.
Okay. Do you want to do that next week?
Yeah, sure.
Okay.
And I personally would find it useful to touch on Appendix A and B, but if you guys are already way comfortable with that, I don't want to hold back the...
I think we'll bring that up next time and see, because I know 3 of the people missing today would not want to do that, mostly because they're physics and geometry, and functional analysis is something they use and they're interested in, but it's not like it's very interesting to see functional analysis again, I'm of the opposite perspective because I'm an analyst. I love functional analysis, but I think maybe we'll hold that discussion off. And yeah, I think tentatively, I might email Dr. Evermedy and Sam and John. Are we missing anyone else? Keith?
Yeah.
Okay. And we might see. But I think that's all I'm going to cover today. I hope that was something interesting. Do you guys have any questions?